At the end of the last lecture, I looked at Hugging Face briefly and discussed the process of finding a model and fine-tuning the model for a specific task. The Hugging Face website, if you've had a chance to visit, you'll see that it contains a lot of content. If you are new to the site, this lecture will guide you through some pages and docs to get you started using Hugging Face for natural language processing tasks. Let's start with the docs. Under documentation, you'll see a lot of categories of documentation. Some of it will be more obvious than others. I'm going to scroll down to tasks, which is described as all things about machine learning tasks, demos, use cases, and so on. And within tasks, I'll scroll past computer vision to natural language processing. So here we see some natural language processing tasks and applications of natural language processing. We are talking about translation this week, so we'll look at the translation task. There is a video on most of these pages, a little short video that describes the task. Some use cases, for example, creating multilingual conversational agents. Inference, so how you can use the Transformers library to perform inference using models. You can copy and paste code snippets there. And then other resources. So there's an entire course chapter on translation and notebooks using PyTorch and TensorFlow, which are both deep learning frameworks. Now, if I just wanted to use some models directly to perform translations, I could click here, Models for Translation. I can browse the models. There's 3,600 of them. Some of these models that I see in the list are general purpose models that can do a lot of other things in addition to translation. And then there will be others that take a general purpose model and fine-tune it for a specific task. And some of those tasks might be translating from specific subsets of languages. I like to sort by most likes, so I'm going to do that. And the most liked model under translation tasks is the Google T5. We'll click on that, and this model gives us a model card for the T5 base model, which explains details about the model, its uses, potential biases, details on how the model was trained and evaluated, and so on. If I want to directly use the model for a small test, I can look at the pre-loaded examples or provided examples, or I can make changes. And since this isn't a provided example, the model actually has to perform the inference. Of course, that was a silly change because I just went from a proper noun to a proper noun, but you get the gist of it. How do we know T5 base model, first of all, is a general purpose model? One thing you can see that this model has a lot of tags, so it's tagged in a lot of categories. Some natural language processing categories we see here: translation, text-to-text generation, summarization. Let's browse the models again and see if we can find a model that is fine-tuned. So perhaps using this base model and fine-tuning it for a natural language processing task. To do that, I'm going to filter by name. Now, by convention, if you're fine-tuning a model, you should certainly use that model's name. in your model name. That doesn't mean that's always going to be the case, but this is a good start. That's a good starting way to try and find models that may have been fine-tuned from this model. And you see that there are a lot of Google T5 models. There's the base model, a small model, a large model. Typically, if you see small or large, that's just going to point to the amount of data the model was trained on. And larger models are going to consume more resources than smaller models. So a lot of times when I'm doing a research project, I'll start with the smallest model I can find while I'm doing my code development. And then I'll swap that out for a larger model when I'm ready to start doing my research and analysis. So let's look at this model. This model is based on T5, and it's translating English, Russian, and Chinese. So the model can perform direct translation between any pair of these languages. We can look at the provided examples. So the first provided example says translate to Russian. The purpose of the development is to provide users with a personalized synchronized interpreter. And that's going to be translated to Russian. And of course, if you're using the model yourself, you're hopefully going to get faster inference speeds than we're seeing here. And you'll see all of the different translations that this model can do, and so on. You can also, of course, go in here and change some of these. So if I have this one that's translating from a language I don't know to a language I don't know, change this to English, which is, if you've been following along with me, really the only language I do know, and see that we get the same sentence. The purpose of the development is to provide users with personal synchronized translation. So I like this one because it goes with pairwise translation capabilities across 3 different languages, so you can really do some comparisons that are direct and comparable there. Of course, you can also use most of the models, a whole lot of them anyway, can be accessed in the Transformers library using a Transformers pipeline, or you can load the model directly. So the pipeline, it's a high-level helper. This just enables you to quickly load models for specific tasks. So you identify the task and the model that you want to work with, or you can directly load the model, which loads a tokenizer for the model and then the model itself. So you can copy that code, paste it to Python, a Python script, and run it locally. Note that when you're running these files from, or these models from Hugging Face, you are often downloading the model and storing it on your hard drive. So be aware of that, and make sure that you have the resources, the time, and the space to perform this before you start running things. And that's another good reason when you're getting started, try to stick to the smaller models until you get a feel for what exactly is downloaded and how much space and time things are taking on your particular system. So I went through a path there of going from docs to tasks, and then clicking on my specific task of interest. And from there, I could browse models for my task. I could also browse data sets to use for my tasks, for my own research. But of course, from the main Hugging Face page, you could also simply click on models, and then on the left, find the task. See all the natural language processing tasks here, and there's translation. And this is going to filter the models to models that do translation. So same place that we got to before with a more direct path. And incidentally then, if you wanted to filter these models even further on a particular language, you could do this here. So we see that adding this language dropped the number of models available to 99. And note that as I'm doing this, be aware that these selections are remaining. So the task that I selected remains. If I go back to tasks, the language I selected remains, and I can go to another task and the language remains. So just be aware of that. I've had people I've had individuals have a hard time finding a model and then realize that they have a language selected, and that's filtering the models to that language. So this 436 models, if I remove my language, becomes 118,987 models. So be aware as you're exploring and clicking on different filters here that those filters are going to stay in place until you unset them. So I could add additional languages, or I can reset the language choices. Same thing with tasks. You can add more tasks, reset to get back to all of the models. And you see there are currently, at the time of this recording, 754,565 models. So learning how to properly sort and filter and get to the models that are going to be most useful for your task in terms of the model's capability and your resource constraints. I hope that overview of Hugging Face helps those of you who are new to Hugging Face target your search on the website a little better and enjoy exploring the things that you can do with fine-tuned models.